Dear students, we will actually look into parametric equations. So we normally write y in terms of fx, but we can also write x and y as a function of a third variable. So mostly in your textbooks, they use the term, the letter t. So for example, if you have equation x in terms of t and this is y in terms of t, these are called parametric equation simply because x and y is written in terms of a third parameter, which is t. So each value of t will uniquely define a point or represent the value of x and y on a curve. So for example, if you consider the straight line equation as such stated, then this is how the line is drawn. You represent it with a set of axes, x and y, and the same line can also be represented by the parametric equation. So for example, say you write x in terms of t and y in terms of t. This is what is meant by two different parametric equations. And for every value of t, that means each value of t will uniquely define a point on the curve. So for example, when t is 1, you get a point of 8, 0 by substituting t1 into x and y. And then when t is -1, you substitute into this equation and you will get another 0.60. It's also possible to eliminate t from a parameter from a pair of equations. So for example, if you consider the parametric equations from the previous straight line example, and x in terms of t and y in terms of t. So in order to eliminate t, there are some simultaneous equation or substitution equations method involved. So for example, you can make t as the subject of equation in x so that you can substitute t in terms of x into the equation y in order to eliminate t. So this is how you can do it. Make t as the subject of the equation of this the first x in terms of t, you make t as the subject of equation and then substitute this into the y equation here. So substitute t as x over 4 minus 1 and then you try to rearrange it, you should be getting the original straight line equation provided just now. So this equation has a term called constraint equation, so it's known as constraint equation. Please note that the parametric representation of a curve is not unique. For any that means for any function y equals to fx, you can define a parameter in terms of any other parameter. It can be u, it can be t, it can be w, it can be z, anyhow. So your understanding is you need equation x in terms of u and y in terms of u in order to make y equals to fx to be defined. So for example, the pair of parametric equation also represent the same line as before. Instead of t, you write it in terms of Hi, now we will look at another example of parametric equations, which are actually parametric equation involving a circle. So for this case, when you consider the pair of parametric equation as x equals to this and y equals to this. So recap back, in order to get a circle equation, you need to have an equation which involves the center and also the radius. So it's the general equation is x minus a squared plus y minus b squared equals to r squared. So you try to write this in terms of that equation. So you have x and y. So from here you can derive that x minus 4 is r cos theta and y minus 3 is r sin theta. So this is similar to x minus a and this is similar to y minus b. So as I said just now, x minus a squared plus y minus b squared equals to the radius. So in this case, the equivalents are r squared theta, r cos theta squared and also r sine theta square. We can further simplify this, and it will become x minus 4 square, y minus 3 cube. I brought this one over on the left hand side. Cos square plus sine square is always 1. So when you factorize r square as a subject, it becomes r square multiplied by cos square plus sine square, which is 1. So it will reduce to r square. So this is a circle equation with the center 4, 3, and the radius is r. So this is also known as another constraint equation similar to the straight line equation in the previous example. The parametric equations are known as the freedom equation. Right? We will now look at more examples to determine the constraint equation of the locus defined by the parametric x and y. So what is meant by constraint equation? You're given x in terms of t and y in terms of t. You have to actually determine y in terms of x and then sketch the curve. So x, y. So the easiest way would be to get y in terms of x would be squaring both sides. So the methods can vary on how to get y in terms of x depending on the x and y given. So when you square both sides, you get this. And the next step, since you have t square, and you have t square, and you have t negative 2, t negative 2, so it will be wise to actually subtract these two equations. Okay? So the first one minus the second one, you will get x squared minus y squared. This function minus this function, you will actually get 4. Because you eliminate square, square, and a negative 2 powers. And so therefore, this is a constraint equation of the locus defined by this parametric. So if you want to have fun drawing it, you can actually sketch this. You can even use the equation grapher or the Desmos graphing function on your phone. And you can actually graph this equation.